Okay guys, let's take a look at today's lesson. Today we're going to be looking at analyzing data. Really 5 specific things. We're going to look at measures of central tendency, which we've been working with for years, right? We've worked with mean, median, and mode ever since probably middle school or even earlier than that. Mean, of course, is the average of numbers. We know how to average things, right? We just add them up, divide by how many there are. Median is actually the middle number. The number, if we would put them in sequential order, it would be the middle number. Do we remember what to do if there are 2 middle numbers? We average them, right? So we remember that. And mode is the one that occurs, the number that occurs the most. And there's a fancy word, bimodal, okay, which just means there's 2 modes, 2 numbers occur the most. But, wow, that's kind of fancy, right? Bimodal, that's a stats word. So now, you could use that word. The other 2 things we're going to look at are measures of dispersion, variance and standard deviation. Now you may not have done much work with these 2 types. Let's talk about what they do. So the variance is a measure of how far the data is spread out. And let's look at this formula and so we'll kind of discuss the formula so we can see what is happening. Mean is usually indicated by X with a bar over it. That just means that's the mean. So look what's happening. This x1, x2, those are the individual data points. What this formula does is it takes the individual data points and subtracts the mean from them, and then squares them, so that makes them all positive, adds them together and divides by n. So it's looking at every single individual value, subtracting the mean, squaring it, adding it together, dividing by n. Now you can imagine if you have, let's say, 30 data points, this would be quite tedious to do. I mean, you have to take all 30 numbers, subtract the mean from them, square all those numbers, add them all up, and divide by 30. Now our calculators are pretty cool these days, and they have a button that we push that does all that for us, and that's why we're going to be using the calculators pretty much today. You're not going to have to memorize this formula because it's actually in your calculator. But I do want you to understand what it does and how it looks, not that you're going to have to do it by hand. Before these pretty cool calculators, you can see people were doing this, by hand or using a computer to do this. So this is the variance. Now the standard deviation measures how much a particular number in the set differs from the mean. That's what this, right? So what has happened with this variance formula? It's kind of increased the numbers, right? It's squared them all. They're much bigger. Look what the standard deviation does. It square roots the variance. It kind of brings them back down to the values that they were prior to this computation. So this little Greek letter is sigma. You can use sigma to show standard deviation, and that is the square root of the variance. And again, these 2 things we're going to be doing in our calculator. All right, so questions about it in general so far? Okay, let's go to the examples. The first examples, I went ahead and I calculated the mean, median, and mode ahead of time just to save us some time. You will need to calculate that with the data, and you can do that on your calculator. I'll show you. It's quite simple. So what we're looking at is which one of the measures of central tendency, so that's kind of a, like a vocab word. What is measure of central tendency? It's those 3 things, mean, median, and mode. Measures of dispersion, it's those 2 things, variance and standard deviation. So it's kind of a vocab word you need to be aware of. And which one of these would fit the data the best? Now this is a subjective kind of question, which, as a mathematician, I don't really like subjective questions. I really couldn't teach English. That would just not work for me. There's too much subjective stuff in there. So know that there's more than one right answer for a question like this. Well, let's talk about it. I'll give you an example. Let's say we have a business that has 30 employees and their mean salary is $60,000. Well, think about the people that are in the business. You would have the boss, the CEO, and you'd have people that maybe passed out mail or something. So you have this wide range. And think about with just 30 people, what if the boss makes 2 million? The head guy makes a lot. and then all the other guys really just don't make that much. It would make it look like it was a pretty good place to work, right? If the average salary is $60,000, I mean, that's not bad, right, for somebody starting off, when in reality it's skewed because the head makes like $2 million. So the average may not be the best descriptor of that information. You know, if you were a prospective employee, you wouldn't really like that as something that would tell you, you know, what was going on, because that really isn't going to be what you're going to make. On the other hand, if you, let's say you're working on, you know, you're like work for the government, like maybe a city income tax or something. Some cities have income taxes. So you'd probably like that, right? If that business makes, if they all, you know, average 60,000, you would want to tax each person on 60,000. I mean, that would sound good. So it really depends on where you're coming from as to if it is, you know, how you want to represent the data. So I'm just going to throw that out there, that it's kind of like an opinion. And so we could, if we could make an argument for whichever one we chose, we would probably be okay, as long as our argument was valid. If we look at this first one, if I'm trying to figure out if mean, median, or mode would best represent the data. If I think about the mean, okay, so it puts at like 4.23 somewhere in here. Would that number represent the data the best? It doesn't look like it, right? Because there's a lot of data to the left and not a whole lot to the right. So I really wouldn't think the mean would do a good job at representing the data. If we look at median and mode, they're pretty close. Like a median, you know, maybe that's a pretty good representation of the data. That you could make a case for that being a good one. And mode, you know, certainly the vast majority that are, you know, 20 of the pieces of data are twos. So you could make a case for either of these two. Probably not a big case for this one, but a case for a median or mode. This is bimodal. It has two modes at 1 and 9 at the ends of the data. That's probably not a good descriptor of all the data. We probably would want to, you know, pick one of these, mean or median, you know, right around here would probably be a good descriptor of the data. And lastly, this set of data, we have the mean at 4.59, median at 5, and mode at 1. Pretty much the mode really wouldn't give us an idea of what that data looked like at all, just because there were more ones. I mean, there were 6 ones, but there's a lot of other numbers. So probably we would choose one of these others. So you do have an example on your daily work where they give you a set of data and you are asked to find the mean, median, and mode, and then decide which one you think is the best descriptor of the data. So you'll have a kind of a question like that. Are we okay with that? So it is kind of a judgment question. Now let's get to something that's not a judgment question. Okay, standard deviation is just a standard deviation. So let's look at number 2. The table below shows students' 6 weeks averages. Find the mean and standard deviation of the data. What % of the data values lie within one standard deviation of the mean? Okay. I pulled this off the internet. That's a kind of painful 6 weeks average right there, but I don't know. It's kind of painful. Some of these are kind of painful, so I'm just going to, let's pretend that it's not a 100-point scale, although there is a 97, so it leads me to believe it is a 100-point scale. At any rate, we're going to work with this data as painful as it looks. And what we'll do is we're going to pull up our calculator. I'm going to pull up my calculator. You already have your calculators out, hopefully. And I'm going to talk to you about how to enter this data. Now, you may already know all this, and that is great. So just bear with me as I'm, you know, maybe there are some people that don't know how to do this. So I'm just going to explain it like pretending like you don't know how to do any of this, which I'm sure you do. So let's see. I want that to be bigger. Okay. Okay, there we go. All right, so let's go to, we're going to go to list. So this little blue button up here, above the stat, goes second list. And here's all of our names right there. That's the list. I actually want to get into the list, so let's go just into, let's quit for a second. Let's go just into stats, because we're going to go into list in a moment, but I want to edit. I want to edit the list. And I want to talk to you about, so we go, it's just stat. Just press the stat button. You should have this screen. Press edit. These are our lists. Now I want to show you how to clear a list because I've made a terrible mistake before, and I don't want you to make it. So what we do is we're going to highlight the L1, because I already have numbers in here. I'm going to re-put those in. You highlight the L1 and you hit clear. Clear. It looks like nothing has happened, but you hit enter and they're all gone. Okay, it's clear. Do not hit delete. Okay, that's what I did. I'm like, oh, nothing is happening, so I'm going to delete. Well, if you go up to the list and you press delete, it's going to delete the entire column. List 1 will now be gone. Okay, the only way to get it back is to reset your RAM. So you have to reset RAM if it's disappeared. And if you don't have one, maybe it's, I don't know, maybe you disappeared it. So just reset your RAM, it'll come back. We don't want to hit delete, we only want to hit clear. Because, so L1 is the list that our calculators default to. It's like its favorite list. So if you get rid of its favorite list, I don't know, maybe it goes to list 2. I don't know where it goes, but I don't want to get rid of its favorite list. I want to keep it there. So L1 is the favorite list. Once we get to L1, we're going to enter all of those 6 weeks averages. So I want you to spend a little bit of time and go down and enter all those numbers. And I will enter them up here and I'll say them out loud in case some of you haven't printed the notes. So 59, and then we hit enter, then 48, then 87, then 70, then 36, then 54, 25, 56, 66, 75, 32, 42, 37, and 97. Now let me tell you, this is the most important thing you're going to do, is to put the numbers in. The most important thing. You really need to check the numbers. If they are off by 1 digit, all your answers are going to be wrong, or if you've skipped one. So just take a couple of seconds after you input the numbers and double check them, and that's what I'm going to do. I'm going to make sure that I have them all in and they're all right. So we got 97, 75, 66, 25, 54, 36. Looks good so far. Let's see, 36, 78. Okay, so it looks like I got them all in correctly. So I really encourage you to please stop and double check. I can't tell you how many points have been lost on an assessment because the data input was incorrect. Alright, so we have the data in there. Now let's explore some calculations that we can do with the data. So let's go into, we'll go to list. Let's go to list. So second stat. Let's go in here. Actually, we need to really get out of here first. Okay, so get to a clear screen. Second, quit. Get out of the list part, because if you start going to other things, it's going to type it in the list. So let's just get out of the list, and now let's go second stat. So we have several things going on. So it lists all the names, those columns that we have over there. We're going to be using L1. Here we have some sorting and this kind of stuff, some sequences, and down here at the bottom we really aren't going to be using anything in here in ops, but there are a lot of things that are available. Most of the stuff that we're going to be using for this lesson, or actually all the stuff we'll be using for this lesson, is under math. So it's list math. See how we have a mean? We have a button that's going to calculate the mean for us. The median they can calculate for us. They can add them up. We're not going to do much of that. Standard deviation and variance. So really this is the menu that we're going to be finding the things that we want to do. What this problem asked us to do was find the mean and standard deviation. So let's find the mean first, which would just be 3. And now I've got to insert list 1 in there. So we would go to second list. There's my list 1. Okay, enter that. And then just hit enter, and that gives me my mean. So my mean is 56. See how quickly it calculated it for us? Isn't that nice? So we would write down, x with the bar over it. That means mean, which is 56. So that's the first question that they asked us, what the mean. So that was not too bad. All right, so the second question is standard deviation. So it's going to go back in there, back in the list, back in the math one. See where our standard deviation is right down here, number 7. Then we're going to pull the list down, which was second list, enter. So there's our standard deviation, and that is 21.2494. All right, so I'm going to write that. I'm going to use the sigma. You can just write standard deviation, but sigma does mean standard deviation, is 21.2494. Okay, so those are the first 2 pieces of information that they wanted. Now let's see what else they want. Okay, so now we're going to have to apply that. So what does this mean? What does the standard deviation mean? It means that that's a measurement of the spread of the data. 1 standard deviation from the mean. What they're asking is what percent of the data values lie within 1 standard deviation of the mean. Well, we need to find 1 standard deviation. This is the mean, right? The mean is 56. We need to find what numbers are within 1 standard deviation of the mean. So what we would do is we would take the mean, and we're going to subtract the standard deviation. And we're going to take the mean and we're going to add the standard deviation. That would be on either side, 1 standard deviation on either side of the mean. So let's do that. So we do 56 plus the 21.2494. And really for this type of statistics, rounding to the hundredths is plenty. We don't need to go to the thousands. If you want to, you can. But hundredths is plenty. So this would be 77.25, and then we take the mean and we subtract the standard deviation, and we would get 34.75. So the numbers that are within 1 standard deviation of the mean range from 34.75 all the way to 77.25. Okay, that's like our range of numbers that are in 1 standard deviation. So now what do you think we need to do? We need to go back and look at the data, and we need to see how many numbers are inside that interval, because that's what the question they asked. It says what percent of the data values lie within 1 standard deviation of the mean. Okay, so let's do that. I don't need the calculator anymore. Let me see if I can get it to go away. Maybe not. Okay. Go back here. So let's look at, I'm going to leave that range there. Alright, so let's go back and look at the data and see, we need to know how many numbers, or first of all, how many pieces of data are there. And there are 14. There's 14 total students that are on here, so it's going to be something out of 14. So let's look and see. We want to know the numbers that are between 34.75 and 77. So I'm going to go through and just kind of circle them. Okay, that one is in that range. This one is. The 87 is not. 70 is. The 36 works. 54. Okay, 25 doesn't work. 56 and 66 and 75 all work. 32 does not work. 42 works. And 37 and 97 doesn't work. So basically, there are 14 pieces of data, and four of them aren't in there. So we know that there are 10, right? There are 10 lie within 1 standard deviation, and they wanted a percent. So we just need to divide that out. You know, just go to your calculator, 10 divided by 14, and you're going to get 71.43%. And let's say back the words they say, of the data lie within 1 standard deviation of the mean. And so that's the question that they asked. Okay? So what our goal is today is to learn how to work with standard deviation, what it means. You know, it's a measure of dispersion, how to use it in cases like this. And then we're going to do more work with standard deviation tomorrow, like the normal distribution and stuff like that. So we're going to do more work on it tomorrow. But I just want you to get familiar with it and work with it. Okay? Any questions on that?